Good day, everyone. Welcome to our math class. I am your teacher and I'm here to guide you in answering your module on our 6th and 7th week. By the way, how's your week 1 to 5? I hope you already have submitted your outputs. Well, congratulations if you are all done. Today, we will be having a new lesson which is about the other kinds of conditional statements. The biconditional, inverse, converse, and contrapositive statements. And in this lesson, you are expected to determine the inverse, converse, and contrapositive of an if-then statement. Recall that the if-then statement is the conditional statement that you have learned in our previous lesson. Second, you have to know how to illustrate the equivalences of the statement and its contrapositive and the converse and inverse of a statement. You should see the relationship between the conditional and contrapositive statements and also between the inverse and converse statements. So, if you are ready, then make sure you have your module with you, and of course, your paper and pen. Let us start by measuring how much you know about the topic that we're going to discuss. First, I want you to get a piece of paper and a pen and try to answer the 2 questions that I'm going to show you. You will be given 5 seconds for every question. Let us have number 1. The converse of the statement, if you are in love, then you are inspired is A. If you are inspired, then you are in love. B. If you are not in love, then you are not inspired. You have 5 seconds to choose your answer. So, which do you think is the correct answer? Is it A or B? Okay, once I clicked on the choices, a smiley face will appear beside the letter of the correct answer. If the answer is wrong, it will show you a sad face. Let's try it. I'll click on letter A, and it shows a smiley face. So it means this is the correct answer. The converse of the statement, if you are in love, then you are inspired, is if you are inspired, then you are in love. Let's have number 2. What is the inverse of the statement, if the number is divisible by 2 and 3, then it is divisible by 6? Letter A. If the number is divisible by 2 and 3, then it is not divisible by 6. Letter B. If the number is not divisible by 2 and 3, then it is not divisible by 6. Your 5 seconds starts now. Okay, let us reveal the correct answer. Is it A? Oh no, it is not. Therefore, it is B. The inverse of the statement, if the number is divisible by 2 and 3, then it is divisible by 6, is the statement, if the number is not divisible by 2 and 3, then it is not divisible by 6. Were you able to answer the 2 questions correctly? Well and good if you did. But if you did not, don't worry. As we move to the discussion of our new topic, everything will be cleared and hopefully you'll make a perfect score in the next activities. Now first, let's recall the last time that we discussed about conditional statements. We know that conditional statements have two parts, the hypothesis and the conclusion. Each part is preceded by the word if and then as indicators of these two parts. That's why they are also called if-then statements. Let's have the example. If the triangle is equilateral, then it is equiangular. Which is the hypothesis in the statement? Take note of the word if. The statement that comes after this word is called the hypothesis. So, the hypothesis in this statement is the triangle is equilateral. How about the conclusion? It is the part that comes after the word then. Therefore, the conclusion is it is equiangular. Is it true that if the triangle is equilateral, it is also equiangular? Yes, this conditional statement states a true statement. What if we exchange the positions of the hypothesis and the conclusion in the conditional statement? Then, the statement becomes, if the triangle is equiangular, then it is equilateral. The conditional statement now is transformed and becomes the converse statement. The converse statement is formed when you switch the hypothesis and conclusion of a conditional statement. Is the converse statement true or false? Yes, it is also true. It is true that if a triangle is equiangular, then it is equilateral. So both the conditional and the converse statements in our example are true statements. Let's take the second example. If a man is honest, then he does not steal. The hypothesis in the sentence is a man is honest. And the conclusion is he does not steal. Let us write the converse of this statement. If we switch the position of the hypothesis and the conclusion, our statement now becomes, if a man does not steal, then he is honest. The statement now is in converse form. What can you say about these two statements? Are they both true statements? Yes. Remember this, class. When both the conditional statement and its converse statement are true statements, then they form a biconditional statement. A biconditional statement is a statement of two conditions that are both true statements. Hence, if you are given a biconditional statement, you can split it into two statements, the if-then form and its converse. The biconditional statement uses the word if and only if in the sentence. Using our previous examples, let us write their corresponding biconditional statements. From example number 1, we said that the conditional statement is true. its converse statement is also true. Therefore, we can write a biconditional statement as a triangle is equilateral if and only if it is equiangular. The statement now is not in if-then form, but with the phrase if and only if, it means its conditional and converse equivalents are both true statements. In number 2, if a man is honest, then he does not steal. The conditional statement is true. Its converse statement, if a man does not steal, then he is honest, is also true. Therefore, we can write a biconditional statement for this statement as a man is honest if and only if he does not steal. Let's take the next example. Two angles are complementary if and only if the sum of their measures is 90 degrees. What kind of statement is this? Correct, it is called a biconditional statement. Now, what statements can you derive from this statement? Okay, we can derive the conditional statement and its converse statement. Now, what is the conditional statement for this biconditional? The conditional statement is, if two angles are complementary, then the sum of their measures is 90 degrees. Correct. How about its converse? The converse statement can be written as, if the sum of the measures of the two angles is 90 degrees, then they are complementary. Is this clear now? Very good. Now, aside from forming a converse statement from a conditional statement, which is done by switching the hypothesis and the conclusion, you can also form the inverse statement and the contrapositive statement. An inverse statement can be formed by negating the hypothesis and the conclusion of the conditional statement, while the contrapositive is formed by negating the converse statement. Example: a polygon with exactly 4 sides is a quadrilateral. Let's give the conditional and the converse statements first. So, the conditional statement is, if a polygon has exactly 4 sides, then it is a quadrilateral. The hypothesis is, a polygon has exactly 4 sides, and the conclusion is, it is a quadrilateral. Switching the position of the hypothesis and the conclusion, we form the converse statement, and it can be written as, if a polygon is a quadrilateral, then it has exactly 4 sides. Now, the inverse statement is formed by stating the negative condition of the conditional statement. Hence, we write it as, if a polygon does not have exactly 4 sides, then it is not a quadrilateral. Take note of the word not. It makes our conditional statement negative. The contrapositive, on the other hand, is formed by negating the converse statement. Hence, it is written as, if a polygon is not a quadrilateral, then it does not have exactly 4 sides. Again, take note of the word not. It is inserted to make the converse statement negative. Take a look at our example number 2. 2 line segments of equal length are congruent. Let us write the conditional statement. If 2 line segments are equal in length, then they are congruent. The hypothesis, 2 line segments are equal in length, and the conclusion, they are congruent, can be switched to get the converse statement. It becomes, if 2 line segments are congruent, then they have equal length. If we take the negative statement of the conditional statement, we can get the inverse statement. The inverse statement can be written as, if 2 line segments are not equal in length, then they are not congruent. Take note of the word not. It makes our conditional statement negative. The contrapositive statement, on the other hand, can be taken from the converse statement. Just get the negative statement of the converse and write it as, if 2 line segments are not congruent, then they don't have equal length. Again, the word not and don't make our converse statement negative. Why don't you try example number 3? You have 2 minutes to complete the different statements. You have 10 seconds left. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and time is up. Now let's see if you have the same answer as mine. So, the conditional statement is, if a figure is a rectangle, then it is a quadrilateral. Is it a true statement? Yes, it is a true statement. Now, the converse statement is, if a figure is a quadrilateral, then it is a rectangle. Is our converse statement true? It is false because quadrilaterals consist of not only rectangles. Squares, parallelograms, and trapezoids are also quadrilaterals. The inverse of the statement is, if a figure is not a rectangle, then it is not a quadrilateral. And like the converse statement, the inverse statement is also false because trapezoids, squares, and parallelograms are not rectangles, but they are all quadrilaterals. And the contapositive statement is written as, if a figure is not a quadrilateral, then it is not a rectangle. This statement is also true. All figures that are not quadrilaterals are definitely not rectangles. Examples are circles and triangles. From this example, the truth value of the conditional and contrapositive statements are the same. They are both true statements. Hence, they are considered equivalent statements. Equivalent statements are statements that are both true or both false. What other statements are equivalent in the set? Correct. The inverse and converse statements are equivalent statements also because they are both false statements. Okay, there goes the biconditional, converse, inverse, and contrapositive statements. If you can answer the next questions easily, then you are ready to answer the learning task in your module by yourself. Here they are. What are the parts of conditional statement? How do you write a converse statement? When can you write a conditional statement into biconditional statement? How do you write the inverse statement? If you negate converse statement, what do you call the resulting statement? Were you able to answer them easily? If you did, then you are good to go. But if concepts are not yet clear to you, you may go over and watch this video again. Here are the tasks that you have to finish for this week. Keep safe and happy working!